Hey guys, welcome back. So today I've got something that I've been wanting for quite a while, but could never really justify the cost until today. I found a deal, at least I think I did, and no, it's not a generator, but it is something that'll be very useful for testing generators. So let's get it out of the box and see what we've got. If you guessed a load bank, you'd be right. This is a Simplex load bank. It's rated up to 10,000 watts of load in 500 watt increments. So we can test anywhere between 500 watts and 10,000 depending upon what generator we are testing. You know, it's pretty basic. I mean, it's just a resistive heater, very similar to the space heaters. The big difference is the price. And of course, it's a professional grade piece of equipment. Now, these brand new, they're around $4,000 or $5,000, and that I couldn't justify. And even used, they're still about $2,500. And when you can get a space heater for 30 or 40 bucks, then yeah, it's kind of a no-brainer. In this case, a subscriber found this one on Facebook, sent me a link. The guy was only asking $700, and I gave him his asking price under one condition, that he would ship it to me, and he did that. Now, the seller didn't know anything about this as far as whether it worked or not. You know, hopefully it does. Otherwise, yeah, we might be fixing a load bank. Anyway, these things are pretty simple. I mean, there's really not a lot to them other than heating elements, a fan, a couple meters, and a bunch of switches. So it should work. At least that's my hope. So that's what we're going to find out. I think before we can do any testing, I need to get a plug on these wires so that we can give it some power. And even before that, I'm going to get the cover off, just take a look inside, make sure there's no red flags, and go from there. Just get those zip ties off, get the wires out of the way. And I also noticed one of the wires has a tag on it. It says something to the effect of article, and it says 200 watts, unknown. So I'm thinking the person I bought this from most likely got this at an auction, hoping he could sell it and make some money. There's a few more here on the back, and I might need to take these off as well. The heating elements seem to be on the top. So when running this machine, we need to have the fan on, and obviously this area unobstructed. There's also an air intake on the back, so we need to keep airflow in mind. Get that little guy off. Yeah, we're not there yet, so I do need to remove these bolts around the heater elements if I want to get the top off. Thankfully, all these screws are the same size. This thing's sealed up tight. There's 3 more in the front. Guess they don't want you getting in here. I've got to say, I was not expecting such organized chaos. I mean, there's a lot of stuff going on in here. Starting, I guess, on the right, we have these two large current transformers right down there on the wires coming in, and those feed up to a 50 amp breaker, which then goes over to this device here, which I'm not quite sure what it is. I don't think it's a breaker, but it does look to be breaking out those large cables into several smaller gauge cables. So that might be the purpose of that device. We got a couple of relays, and it looks like a temperature sensor right here, and possibly another right there. Maybe one for monitoring, where the heating elements are, and then another one just to monitor the general temperature in here. Otherwise, there's not a lot going on. I mean, we have a bunch of wires going over to the heating elements. We have two fans in the bottom, and then a bunch of wiring for the switches and the gauges. So we've got a gauge for volts, amps, hertz, and then we've got one for fan control and the master switch, and then these are all the different loads we can put on. 2 for 500, 1,000, and then the remaining ones are 2,000 each. Anyway, I'm just going to blow out some of this dust, maybe quickly clean this up a bit as well, and then I want to get a plug on these wires. We'll power this thing up, see if it comes to life. Judging by the amount of dust on here, I'd say it's been some time since this thing has been used. I was really kind of hoping to test the condition of the switches to make sure everything's working properly. But when I connect the multimeter, I don't get anything, even after turning on the master and all these switches here. So this mystery device, I'm thinking actually is a relay. We have the two big wires coming in here. We have two little ones right there, which most likely energizes when you flip that master switch. So yeah, I guess we're going to have to just power it up and see what happens. So to that end, I'm going to temporarily connect this 50 amp plug to these wires here, which I think for the most part will work. I guess my only concern is the neutral is a really heavy gauge wire, and that's in case you want to run this in 120 volt mode, you need to carry twice the current on the neutral. Whereas in 240, which is how I'm going to wire it, half the current is going to flow on each of these legs, and with a balanced load, nothing should go on the neutral, or at most half load. So yeah, let's see if we can get that to fit in there, and then we'll try to power it up. I'm going to be limited, at least for the initial test. I have 30 amps available in the garage, not 50, so I will have to adapt this down, and we'll be maxed out at around 7,000 watts. And my hope is, if I can get this thing together in time, to actually try it on a 10,000 watt generator. I still have Jason's XG 10,000, which is rated at 10,000 watts. So hopefully he doesn't take that back before I finish this. Yeah, I'm not especially impressed with this design. The ground goes right there, and you're supposed to sandwich it between one of the legs, which is fine as long as this insulation doesn't fail, but geez, if it does, hopefully the circuit breaker works. I will say this is very high quality insulation. I was kind of wondering what to do about this because I would prefer to have a cord like we're sleeving instead of exposed wires. Just doesn't offer as much protection. In this case, though, this insulation is very high quality. So it might be okay to run like this. Good enough. It'll have to do for now. There's really nothing for strain relief. So this seemed like a good idea, but without a cord, just wires going into it, it's not going to offer too much strain relief. So we'll definitely need to replace that sooner than later. I'd be lying if I said I wasn't a little nervous. Anyway, this is just an adapter to convert it from 50 amp to 30 amp. And then I'm going to use the 30 amp generator cord to feed it power. So this cord has no power yet. So let's flip the switch. See what happens. It's the moment of truth. Circuit breaker's off. So we'll just plug this in and flip the switch. So far, so good. The voltage gauge, it's showing about 248 volts. So we can double check that in a bit to see how accurate that is. And the hertz looks like about 62 hertz. So these might be a little bit off. I don't know if they're adjustable. We'll double check that later. And of course the amp gauge, that's at 0 because we're not pulling any amps. Now we have two scales here. The one on the top goes to 50 amps and the one on the bottom goes to 100 amps. So if I was in 120 mode and I had it wired for that, we could go to 100 amps at 120 volts. Because we're on 240 and that's how I'm wired, the max is 50 amps, and in this case, 30 amps because we're using that adapter. So let's turn the fans on. Both fans are on. We'll turn the master on. And that relay just made a loud click. Let's try 1,000 watts. And the amp gauge moved a bit, but I wouldn't say it's that accurate. Let's try 2,000. Another 2,000. So now we're pulling 5,000 watts. We can go up to 7. And now we're very close to 30 amps, which is the max that cord is rated for. So we'll take some of that off. We're still at 5,000 watts. Let's bring it up to 6. No problem. And the beauty with the master switch is that we can now test from no load to full load, just like that. And I'm guessing a lot of portable generators are not gonna like that too much. But it will be interesting to see which ones can handle it. Let's just try these last 2 switches. So we're at 6,000 watts. 6,000 watts again, so good. Everything here seems to be functional. And I feel a bit of heat, but not too bad. So good. I'm just gonna let it run for a minute. We'll let it fully cool down. And I think we can put the top on. Everything seems to be working the way that it should. And yeah, the gauge, it's a little bit off. We're at 239 volts, and that's probed right on the back of the gauge. So, I mean, there's no saying that this is right, but it is supposed to be a 240 volt service, and I've never seen anything really any different from that. So, yeah, I did take a quick peek. I didn't see any adjustments or potentiometers, so that is something I'll have to look into. I would have to believe there is an adjustment on this. Just going to test the accuracy of the amp gauge. Bring it up to 7,000 watts. It should be right at 30 amps. And yeah, that gauge seems to be accurate. Let's double check the hertz. Yeah, and the hertz are a little bit off as well. We are just about at 60 hertz, or at 59.97. And this gauge is saying we're closer to 60 and a half. So again, not a big deal, but it's something to keep in mind and potentially adjust if we can. I think I lucked out on this one because everything seems to work. So let's get the cover back on, and then I want to move on to figuring out how I'm going to use this with the generator. You know, I'm not too happy with the setup back there with the cord, and we're going to need some sort of a cart to put this on. I picked up 15 feet of this 8 gauge cord, and I was kind of going back and forth as far as whether I wanted 8 gauge or 6. There's nothing wrong with using 6. That's good up until about 55 amps. You know, in this case, we're only pulling 10,000 watts, which is 41.6 amps. And for something like that, 8 gauge wires should be fine. So I decided to use 8 gauge, and actually that's what they originally used as well, at least on leg 1, leg 2, and the ground. And since we're not running in 120 mode, we can downgrade this 6 gauge neutral to a 8 gauge, and I think we'll be fine. So let's just finish moving this over. I've already got it installed. I just got to put the cover on, and then I'm going to get the old wires uninstalled. I want to see how much sleeving needs to be stripped back. We'll take care of that and get this new cord installed. I guess the only downside on using the 8 gauge is that this connector was really expecting 6 gauge. So I did have to cut off some pieces of this insulation and just kind of wrap it around it. So that way, when tightening down on this, we get some strain relief. Gonna remove these 3 bolts down here. Hopefully I can get the control panel a little bit out of the way to give me a little bit better access to what I need. That should be fine. Each of these legs, they're wrapped around the current transformer, and that's how the gauge on the front is able to measure. So when we put the new wire in, we're going to have to do a loop through it, just like the old. So using the old wires, we'll just line these two up right there. And just use this as a gauge. So we know we need to strip it back, I'd say a good 2 feet, right to there. I think that'll be good for the ground wire. And I have the next size up for the neutral. Let's see if that fits. Nope. Let's go up another size. Yeah, that'll be fine. All right, pretty much ready to go. We've got the load bank connected to the 50 amp 240 volt plug. So the plan is to get it started, we'll let the engine warm up. We'll put a half load on at 5,000 watts. We'll let it run like that for a bit. We'll double check the output. From here we can see the total harmonic distortion, the exact read on the voltage and the hertz, and we'll kind of compare that to what we see on here. Anyway, this machine, you've seen it before. This is the one that had the governor issues. And in that video, I did test it up to 9,000 watts, and this thing performed quite well and actually had the lowest THD I have seen, just beating out that Gen Pro. It was around 4%. So yeah, let's get it started. We'll bring it up to the max and see how it does. So we're starting off at about 3% THD. Voltage is 245 volts. And let's take a look at the hertz. 61 hertz it looks like. So yeah, pretty close. I mean, the gauge here says 62 and 250 volts. So yeah, let's bring on the load, see how it does. 237 volts, 58.7 hertz, not too bad. And the THD is at 4%. Let's bring it up to 7,000. 8,000. It is struggling a bit. Let me take off 1,000. So now we're at 9,000 watts. $10,000 watts. So we're at 235 volts. THD right at 4%. 58 hertz. Not too bad. So I'm going to try now to put a load on suddenly. With the space heaters, 1,500 watts is the max I would put on at any one time. So right now we're at 0 watts. Let's put on 3,000. No issues handling that. We'll turn the master off. Let's try 5,000. So right now it's 0 watts. Handled that all right. And let's try just a bit more. We'll go to from 0 to 6,000 watts. Yeah, not too bad. It handles it pretty well. No issues to report. Load bank did well, and so did the generator. It's pretty impressive, actually, the way it performs. 4% THD under a 10,000 watt load, that's pretty good. Not to mention we went from 0 to 6,000 watts and the engine was able to recover and keep running. So yeah, not too bad on both fronts here. Anyway, I think this video is pretty much a wrap. There's really not much more to do here. I think the biggest outstanding item is finding some safer leads. You can see we do have some metal exposed there, so that is definitely a shock hazard, and it's like that on both ends. So I need to get that corrected, but with this setup, we can check almost everything we need to. We got the volts, the amps, the hertz, and if we want a more exact read, we can double check the volts and the hertz here, as well as the distortion. So this should be a pretty good setup moving forward, at least on the larger machines. I think on the smaller ones, I'll continue to use a couple space heaters and the kilowatt, but this is kind of a game changer. So I hope this video helps someone. Thanks for watching.